Thanks everyone so much for joining this Tech Tuesday today. I hope you're staying safe, staying healthy wherever you are in the world. This is a really useful one that we're going to look at today. And it's architected around just a common pattern that we see across myriad different industries and different verticals. And it's focused on this notion of a private data marketplace. Specifically, blockchain is not suitable to have sensitive or large or private data stored on it. Instead, you need sort of these ancillary storage services to keep that sensitive, protected data off the blockchain. And then you need a nice, convenient way to reference that on the blockchain, right? Maybe a hash pointer along with some metadata. And then in an ideal world, what you really want is you want the actual transport rails to securely disseminate and share this data in the scope of your business network. So we're going to look at the patterns and we're going to look at the orchestration to let those techniques happen here. And as I said, this is not scoped to a specific industry or a specific vertical. This is completely applicable to healthcare, to trade finance, to real estate, legalese, NGOs, you name it. There's all different tranches and different categories of sensitive, private, large data, and all of those can be utilized with these services and with these techniques. So our agenda, what we're going to do today, and we'll look at all of these in more detail, we're actually going to start out by building a consortia, a business network on Kaleido from scratch. We'll stand up a few nodes, we'll create what we call a contract project, we'll expose some REST APIs for our smart contract, we'll interact with it, we'll look at the way that other participants in the network can ingest state changes via event streams rather than having to do polling or having to do queries directly to the blockchain. Then we'll look at some of these off-chain storage techniques and where the accompanying crypto material gets stored. And then we'll weave all of those pieces together with a nice veneer on top of it and actually look at a full stack application that utilizes all these services. And that could be applicable to any of those industries or verticals that I just outlined. So a couple slides just to give you an intro on Kaleido, and then we'll hop right into it. So three core tenets really define Kaleido, built for modern business networks. So we provide the backbone, we provide the infrastructure, all of the core runtimes, all of that HA and DR that you need to have a reliable enterprise blockchain network and to have access to all of the accompanying services. Completely business and industry agnostic. So I'll say it again, but the infrastructure, the network, the platform can be used for healthcare, for government, for trade finance, and any industry that can benefit from an enterprise blockchain orchestration can leverage and utilize Kaleido. Radically simple. You'll see this in sort of two different tranches here. The platform itself from a UX standpoint and just from a click button simple standpoint, very, very intuitive and very easy to wrap your head around. But then from, more on the application side, from a programmatic standpoint, we've built a lot of easy buttons, we've built a lot of shims and a lot of abstractions, and we've provided a very, very consumable, a very simple in a good way, RESTful API for every service or every CRUD operation that would otherwise be available on the platform. And then lastly, very much built for the enterprise. So enterprise is in the DNA. It's in the bones of the platform, with high availability, with disaster recovery, with advanced key management, identity integrations, auto scaling, you name it. You get a lot of these things out of the box, even on our free starter plan in Kaleido. And then as you climb up the mountain, as you progress to different subscription tiers, you unlock more and more capabilities around integrations or key management, for example. So this slide's really reflective of what we want to touch on today. And this isn't to trivialize the actual blockchain piece, the nodes and the smart contracts, but it's really to shed some light on the fact that they're a rather small portion of the overall stack when you kind of look at all the different components that really go into a fully looped, a proper, full stack application. You have a lot of questions that you need to answer around, data, around events, around privacy, around integrations, and around, the architecture of the application. And this is really cool for us today because we're actually going to get to touch on all of these layers right here. We'll look at how we store data off the blockchain and how we communicate with that data, how we share it. We'll look at different transaction approaches and how to consume events that are coming out of the blockchain. We'll look at these business-to-business collaborations, how to do encrypted end-to-end transport. And then we'll look at the fun tier, the actual application tier, and see, how do we write our app server? How do we speak to those smart contracts and those APIs? And then how do we weave token digital assets into this overall paradigm right here? So this slide is really a nice encapsulation of everything that we'll do today and everything that we'll get to look at with this application. I think this is the last slide, maybe one more. But our goal at Kaleido really is to just flatten the curve for you as you're adopting this new technology, as you're hardening and identifying your MVP, your pilot, your use case, and easily getting you to production, right? Where you have the confidence to do shared IT, to distribute the ownership of all these assets inside of your business network, and then to have the confidence to be able to scale this network, right? To be able to add new participants, to be able to, increase the throughput, increase the run times, and add additional components into the overall stack. And you'll see how easy that is to do on Kaleido, sort of as we start building our network. So I think that's good on slides right here. We're happy to work with you. We can discuss this offline. I'll share all the contact emails and all the ways to get in touch with us. But we've done this with a number of clients of creating bespoke packages and trying to not have this as a one size fits all, right? Every business, whether you're an enterprise, whether you're a startup, is at a different stage of their journey. So we try to create custom bespoke packages, or simply just the pay-as-you-go route to try to meet everyone where they are in their journey. So whether it's a POC, whether you're getting closer to pilot, or whether you actually have all your hardened, smart contract code and application code and integrations, and you're ready for production. So happy to, we'll touch on this at the end, but this is definitely available for customers of all sizes in the platform. So just a few pieces of admin before I dive into the actual platform. Let me move my Zoom bar right here. This is recorded and we will send it out. We've been doing these for close to a year now. This kind of aligned with the ugly onset of COVID last year, as everyone did a lot of work from home, and digital really amplified. So there's a lovely library if you just go to YouTube and search Kaleido Blockchain. And you can see all sorts of different presentations, around the platform in general, around specific services, maybe key management or maybe private stack, more details on document stores that we're going to look at today, and then a lot of joint presentations with clients and with customers. So if there are any previous Tech Tuesdays or Walkthrough Wednesdays that you're interested in, these are all nicely indexed and curated. You can just YouTube Kaleido Blockchain. And then the last thing I will add is that what I'm going to take you through today, everyone on the call is able to do perform all these actions and experiment with all this functionality actually on the free starter plan on Kaleido. So you can just go to kaleido.io and you can click create an account, and in about 30 or 45 seconds you should have your own permissioned Kaleido organization, and underneath which you can create business networks and environments, etc. Okay. So what we've done here is I've just logged into my Kaleido account, and what I'm going to do is I'm going to create a business network. I actually have an existing, we call it a consortia or a business network. I have an existing one in case things go wrong, but what we'll try to do is we'll try to do everything from scratch, and then we'll revisit some existing resources that sit underneath our application. So first thing I'll do is I'll create my network. We'll call this, I don't know, 216 Tech Tuesday Demo Network. I could optionally upload a mission statement or some legalese. I'm going to skip that. And now I want to whitelist one of the cloud providers in one of the regions that's available in Kaleido. So you'll see we have a nice variety of choices across Amazon and across Microsoft Azure. And what this will do is this is going to be the home region for the consortia. So it's going to store some high-level metadata and some information about the memberships and participants. But it's also going to whitelist the cloud provider in the region for us to be able to deploy nodes and deploy services. And what you'll notice, though, is that this isn't a single choice. You can create a business network that's across clouds and across multiple regions. So, when we have these, modern business networks that have disparate participants in different geographies, and you have different hardened cloud estates, you don't want that barrier to be, we have to choose AWS, or we have to choose Microsoft Azure, or we have to be on premise. All of that is available. All those combinations are available inside of Kaleido. For ease of simplicity, I'm just going to stick with AWS in Columbus, Ohio. But you can see here how easy it would be to whitelist these regions right now, or I could also do that after the fact. So here's our network dashboard right here. We haven't really done anything. This is just the namespace for our business network. My organization inside of Kaleido is called Org ABC. So I'm going to be attributed the first membership inside of this business network. And now a common technique, a really useful technique right here for, early stages of exploration and early stages of pilots or proofs of concept, rather than immediately decentralizing your network and sending invitations and onboarding external participants, what you can do to really accelerate that process is you can just create multiple memberships under your organization's control, and you can mock out the future participation of how your network might look. Right? So we can logically bind nodes and services and security credentials to these different memberships. Once you have all that scaffolding and all of that architecture, basically, and all those relationships mapped out and hardened, then it's quite simple for you to perform your demos, shop this upstream, in your own departments, and then ultimately decentralize the network, actually extend invitations and onboard other participants with optional permissions embedded as well. So this is what we're going to stick with today. We'll skip the invite organization piece as well. So again, this is just the business network, the consortium, the namespace, and I created 2 memberships, both owned by my root organization. Now what I want to do is I want to create what we call an environment. And so underneath your business network, underneath your consortium, you can have multiple namespaces, multiple environments. Each one is firewalled, each one is its own isolated instance. So all the nodes, all the services, all the credentials, and the underlying blockchain and world state, that's completely confined to each environment. So I can call this one, oops, I need to extend my session, sorry. All right, let me move the Zoom bar one more time. Sorry, bear with me. Got logged out. Okay, so we want to create our first environment. So we have 2 doors we can go through here. We can go through Ethereum or we can go through Corda. I'm going to go through Ethereum today. I'm going to call this Dev 1, and I'm going to just go with a cloud-only approach. If you are interested in private stack or on-premise deployments, just reach out to us and we can discuss that in more detail. So underneath the Ethereum umbrella, we have 3 different clients and multiple algorithms to choose from. So you have Geth, Quorum, Hyperledger Besu, and then Proof of Authority Raft in Istanbul. I'm going to go with Geth and Proof of Authority since we don't need to do any private transactions today, and we're just going to do sort of a lightweight orchestration. But if you did want support for private transactions, or you did want to utilize Istanbul BFT as your algorithm, you'd want to choose Quorum or Besu right there. And if you do need to do any advanced configurations, changing the block intervals, adding a custom chain ID, or pre-funding an account, you can do that in this section down here. So we have a Geth POA namespace right here, and now we want to bring it to life. We want to create a couple nodes. So I'm going to create node number 1. I'm going to bind it to organization ABC, to that membership, and I'm going to deploy it in AWS US East. Not going to spend a lot of time on this page, but this is just a quick snapshot, a quick option to integrate with existing services in your private cloud account. So maybe you want to integrate with the AWS key management service. You want to integrate with Azure Blob containers or AWS S3 buckets for business continuity, CloudWatch logging groups, private link, IAM integrations, etc. all these are available for you to kind of add heightened control, heightened security, or just heightened functionality into your core node runtime. And then the last thing we need to do is we need to choose a t-shirt size for the node and choose if we want it to be a signer, if it's going to be able to propose blocks in the algorithm. One thing to note here, these are not binary decisions either, just the same way we can go back and we can whitelist additional regions and cloud providers, can actually dynamically resize your nodes. And this is important based on sort of the horizontal scale of your application, and also sort of the chattiness of your application, the requests per second and the amounts of queries or polling you're going to do on your node. So there is rate limiting involved with the Kaleido runtimes, specifically with the nodes, but also with some other services. This is all documented, and we can point you to the documentation, but a small node, for example, can sustain 5 concurrent connections and 5 requests per second. So if you see your application is going to scale much more broadly than that, or you're going to need more, TPS, then you can upgrade to a medium or a large node. Or again, you can also dynamically resize these nodes prior to those known bursts or surges of transactions. So I'm going to add one more node, and I'm going to give it to our other membership right here. Let's call him node 2. And we'll make him a signer and a small node as well. So these containers, these pods, this will take about 30 to 45 seconds to come up. And as they are joining and initializing, what we'll do is we can go back to our network screen and we'll create our contract project. So this is one of the first things we want to draw everyone's attention to. So this will be used in the actual overall application that we demo at the end. And the idea here is that if you teach Kaleido about your business logic, about your smart contract, about your source code, you're going to get 2 things. You're going to get what we call a compilation under the scope of a contract project. And this is going to give everyone inside of the business network transparent and shared line of sight into what source code, what smart contract logic they're executing on chain. You'll be able to map this back, to the exact source of truth, whether it's a public or a private GitHub repository, or whether it's just surfacing the bytecode in the interface where you could compile that and you could compare and contrast. What this is also going to do, perhaps more valuably from the application perspective, is this is going to expose REST APIs for all the methods available inside of your smart contract. So what you can do with this model here is you create a compilation underneath your contract project, and you can promote those single compilations into any of your environments. So you can follow logical DevOps pipelines, promote your initial contract into, your dev or your sandbox environment. You can iterate, you can harden, then you can take that exact same logic or a new compilation and you can push that into your pre-prod or your staging. And you don't have to do these redeployments. You don't have to do any new compilations. You can just have this logical progression and this logical promotion. So if we go back to our network layer right here and we click on our shared assets tab, we'll see this contract projects utility right here. And what we want to do is we want to create an Ethereum contract project for a very basic smart contract, but we're not interested in the actual source code. We're interested in the programmatic interaction with this smart contract and how easy it can be. So this is the namespace, and now underneath it, I want to create my first compilation. So I'm going to click this new compilation button. I'm going to give it a version 1, and then I'm going to give it the path to where my source code lives. So in Kaleido, we have a number of public Git repositories, one of which is this JavaScript repository with some sample smart contracts and some sample Web3 JavaScript, some code if you want to, go the Web3 client route to interact with your smart contracts. So here's the source code. It's not interesting, as I said. It has a single variable that's a positive integer, and then it has 2 methods. It has a set and it has a get. What it also has, though, it has an event defined called data stored right here. And what we'll notice, we'll come back to this here in a second, but every time we call the set method, it's going to emit this event. So what this allows for is for other participants in the network, node 2 or node 3 or node 4, for example, to have these reliable ingestions or deliveries of these events if another member invokes this smart contract right here. And we'll see how easy and how powerful that is with this source code, but also with the actual application as well. So I'm going to copy this URL right here. I'm going to teach Kaleido about the URL, and then Kaleido will auto detect all of the other parameters right here. So I'll just go ahead and click finish. And in about 10, 15, 20 seconds, what we'll see here is a status change from compiling to compiled. And we'll see that bytecode, we'll see the ABI, we'll see the dev docs, and we'll see this source of truth, even including the git commit hash and the sol C version that was used for compilation right here. And then what we'll be able to do is we'll be able to take this compilation and we'll be able to promote it to an environment. And by doing so, we'll turn all of those methods that we just looked at, the root post and then the sets and the gets and the queries, we'll actually turn those into simple REST API calls for us to invoke. So this is compiled and we see all of that metadata that I just enumerated. So we see the source of truth, the path back to where the source code is, see the commit hash, the sol C version, and then we see the interface and we see the bytecode. So what we'll do now is we'll actually promote this to that environment that I just created. So I'll give it human-friendly endpoint, call it SS, shorthand for simple storage. And this will expose us right here, what we call a gateway API inside of Kaleido. So I'm going to go ahead and view this gateway API. I'm going to view it through node number 1 right here. And then what we'll do is we can actually just click View API, and this will provide us with an embedded Swagger interface inside of the platform. So View API. So now what we want to do is we actually want to look at sort of this paradigm that we're interacting with these smart contracts through. And that's what we call our REST API gateway. So this is an incredibly, incredibly powerful piece of middleware that's built directly into the platform. It's available on every single plan. And what it does is it removes the need for you to become an Ethereum expert, a blockchain expert with these really complicated SDKs and client libraries. And it also removes the need for you to re-architect or inject those thick libraries into your hardened applications and your existing back office systems. Instead, all you need to do is teach Kaleido about the source code, which we just did. That's going to expose those REST APIs. And now you can speak to this smart contract through basic lightweight JSON, right? Just doing simple post calls synchronously or asynchronously into the network. And what this shim right here, what this middleware layer will do is it'll deal with all the hard things in Ethereum. So it'll deal with compilation, it'll deal with RLP encoding and type mapping. And really, really powerfully, what it'll do is it'll also deal with the ordering and the sequencing of transactions. So anyone that's worked in the Ethereum space and done application development, you're very likely have run into nonce mismanagement, making those get transaction count calls. So having this built in right here and allowing you to just asynchronously fire calls into the network, and knowing that it has Kafka underneath the covers, for reliability and guaranteed delivery, but also that it's going to do all of the Ethereum heavy lifting is really, really powerful. Inside of this layer as well, you have a really flexible variety of key management techniques. So what we're going to do is we're just going to use the default account that comes on the node, the 0 account in the get array. But what you could do is you could also sign these transactions with accounts that are held off platform, right? Maybe you want your private key to be in a cloud HSM service on Azure, on AWS, or in a HashiCorp server. Maybe you want to make these anonymous transactions and you want to use an HD wallet service, or maybe you wanted to use that HD wallet service for end user management. So tons of different techniques, and there's also various other managed wallet services inside the platform. All you have to do is just use a single parameter, enumerate that account, that hex string, and Kaleido will figure out where that key is and sign that transaction on your behalf. Okay, so back into the platform. So that's the layer that we're working with right now. That's how we're speaking to this gateway API initially, and then we'll be speaking to an actual smart contract instance. So the first thing we want to do is we want to just take this root post method and we want to instantiate the smart contract. We want to turn those gateway APIs into an actual on-chain, what we call an instance or a deployment of the smart contract. So the constructor wants just an integer for the initiation value, and then what we have is we're auto detecting that 0 account that's on node number 1 right here. So this is the parameter where if you wanted to sign with a different address, you would just simply enter that account in here. So again, that account could be in the HSM, it could be in the HD wallet, it could be on the node, or it could be in another managed wallet service. Kaleido will do all the other auto detections, so it'll do the gas estimation and provide the gas on your behalf. And then you can lastly choose to use this KLD register parameter right here, and you could give a human-friendly name to your smart contract. So rather than talking to a hex string, you could talk to something that's readable or human-friendly right there. So go ahead and click execute. Again, I'm doing this in the platform, but in a second here, I'll go ahead and use Postman to show you how to do this, closer to a proper programmatic call. And we see that this is now, a successful transaction or successful instantiation. And if we go back to our Gateway APIs view, what we'll see is we now have an instance. We now have an on-chain instance of those definitions, of that compilation, of that source code. So we can go ahead and we can view this instance API. I'll view it through node number 1 again right here. And then we could choose to continue to interact with it, or we could just do, like a quick query, for example. So I can click try it out again. We can do a query, and I'll see back 1, 2, 3. Okay. So now the next thing we want to do is we want to look at how the event streams kind of weave into all of this. So again, we see the power of having these real-time notifications, understanding what else is happening inside of the network, and how valuable and how critical that is for your business networks. So the event streams is actually the bidirectional or the other direction inside of the REST API gateway. So transaction submission, we call that ETH Connect, right? Doing Ethereum JSON objects and allowing Kaleido to transform those into properly sequenced and signed transactions. And then the outbound portion of the REST API gateway is what we call event streams. So this is also using Kafka under the covers, and this is going to deliver any events, any state changes that you tell Kaleido that you're interested in to an endpoint, to an API gateway, to a Lambda function of your choosing. And what you can do with these event streams, this is incredibly, incredibly useful and powerful, is you can start building your own local rich caches of the current state on the blockchain. So you're going to have a one-to-one synchronized view of any information that you care about. And you can go and grab all the historical transactions as well. So if you're a latecomer to the network, you can go get every single event starting from block 0, and you don't have to go directly into the blockchain to do queries or to do polling. You can have your own rich database sitting right next to your application for those, really fast, really powerful queries. And then you can go a step further. You can take these events and you can send them downstream, and you can start automating your own business logic or your own back office processes as well. So what we'll do here is we'll do a little bit of configuration. We'll set up node number 1 to invoke this smart contract inside of Postman right here. And then we'll create an event stream on node number 2 so that when node number 1, right, another participant in the network, invokes this smart contract, adds new data, for example, that node number 2 and its application, its organization, is automatically notified of that state change right there. So bear with me as I doctor up Postman real quickly here. So here's our endpoint for ETH Connect for node number 1. We're going to want to call the set method, and then we need to doctor up 2 different parameters right here. We need to tell this xKaleido from this query parameter what the right address is to sign with, and then we need to have application credentials. We need to have this call, secured via TLS. So we do that in Kaleido with what we call app creds. So first thing I want to do is I want to grab this account from node number 1 right here. It's this guy, so I'll just copy it right there on the clipboard. And then we want to go get some application credentials for node number 1 as well. So we can click the security tab right here in apps and integrations, and we can create a new app cred, call it ABC1 right there. And then we want to take the username, and we want to take the password as well. And what I'm going to do in this transaction submission is I'm actually going to submit this asynchronously. So we had 2 approaches. we can actually submit it synchronously and we can wait for that to fully execute and for the response to come back, or we can submit it asynchronously. And what this will do is this will actually create a receipt in the Kafka receipt store that's going to have all of the information about the transaction once it gets executed and once the node basically emits that event. So if you set this X Kaleido sync parameter to false, you'll get basically a real-time or an almost immediate response from the Kafka request topic, just saying, hey, we've received this transaction request. Here's the ID that you can track downstream. And then here's the number of messages that you've sent into basically into this topic right here. So this all looks good. 1, 2, 3 set. If I look at my body, I'm going to give it an argument of 15, and we can just go ahead and invoke this right here. So there's the immediate response that comes back from Kafka. And what we care about actually is this ID right here. This is what we'll be able to track downstream into Kaleido. So if I copy that and close this, and I'll duplicate that tab, and then we'll just call a get. We'll call a get on this route right here. So we'll say replies, we'll give it that ID, and then we'll just change that to a get right there. And once that transaction's executed, we'll be able to get back the full response of what came into the network right there. Okay, so those are the two different routes, a synchronous transaction submission versus an asynchronous transaction submission. If I did this again and I just changed this to true right here, then this will take, based on the block intervals, true. Based on the block intervals, this will take, typically between 4 to 6 seconds for this to return. So we can try this again, sort of with a synchronous model, and we'll, what was that, about 2.5 seconds right there. Okay, so again, we're acting as node number 1 right here. Now what we want to do is we want to go to node number 2, and we want to configure an event stream so that it can understand, what is the new data being written to the network, being written to this smart contract. So we'll click on our blockchain, click on our nodes, and I'm going to go to node number 2 right here. And I'm going to click on the event streams tab. So we're going to call this simple storage, and we're going to go with a webhook. And what I'm going to use is I'm just going to use this little subdomain service request catcher. In the real world, this would be a Lambda function sitting behind a API gateway on AWS, for example, some sort of serverless function. All right, so click next, and now we want to teach it about the endpoint where we want these events to be delivered. And so I'll just create Kaleido 1, 2, 3 right here, and I'll go ahead and copy this. And this is what I'm telling Kaleido to deliver the events to. Okay, so that defines the event stream. And now what we want to do is we want to create subscriptions. So if we've taught Kaleido about the business logic, about the smart contract, Kaleido will auto-detect all of the available events and all the available signatures that are available for subscription. And if we remember, when we looked at the simple storage smart contract, we had one called data stored. We have this event right here, data stored, that's going to be emitted, and it's going to give us the argument every time we call the set method right here. So that's what we'll name our subscription, data stored. And now we can choose the gateway API. We only have a single one right here, simple storage. And then again, Kaleido is going to auto detect that event for us. So we see it right there, data stored. And now I can choose to say, hey, I want all the events for this particular smart contract, or I want all of the events that just match that signature. Maybe I have a bunch of different smart contracts that utilize the same logic and have the same event. You can choose to take all the events, or you can scope them down to a specific smart contract instance. We only have one smart contract instance, so it's kind of a moot point for this demo right here. But that's also a really powerful technique or configuration parameter that you can utilize as well. Okay, so we've configured the event stream, we've configured the subscription, and now what we should be able to do is we should be able to look on this, and if we go back to our postman and we invoke that smart contract again, synchronously or asynchronously, we should see the event returned to that endpoint. So let's change this to 16. Let's invoke our smart contract. And again, as soon as this is executed, that event should be emitted, delivered via Kafka under the covers, and then ultimately to the endpoint that you've configured. So we see the smart contract address, we see the block number, we see the TX hash, and more interestingly, what we'll see is we'll see the argument that was passed here. And you can define your events and code your events to be much more interesting. You can include the message sender, for example. Makes a lot of sense to want to know, who's writing the data into the network. Which end user did this which organization does this end user, belong to, or other data as well, right there. So those are the event streams. Hopefully, you can see how valuable and how powerful those are. And we'll look at those shortly here again with the full stack application. So the last thing I want to touch on inside of the platform from scratch is our off-chain storage utility service. So we call that the document store service. So if I go back to my pictures here, this is what allows us to have a service that can sit next to the blockchain, but actually keep that data private, keep it secure, and keep it protected. It also provides you with the transport rails for you to do secure end-to-end transport to other participants in your business network. So this is completely off the blockchain, and you as application developers, as a business network, you have the power, you have the ability to choose how you want to reference this data on the blockchain. What these services will do, whether it's our document store service or whether it's our app-to-app service, it's going to give you this enterprise transport infrastructure, again, with Kafka under the covers, to do PKCS7, symmetric and asymmetric encryption, to do this enveloping, to do this compression, to do this sharding, to do sign verify logic, and give you this really, really elegant, powerful transport layer that you can then extrapolate and leverage how you see fit. This data does not have to be persisted on Kaleido either. You can very easily integrate into your existing cloud storage services, so blob containers or S3 buckets. And what Kaleido will do is Kaleido will just mirror the presence of that data. It'll hash it for you if you want to hash it, but it's never going to persist that private data. It will do the transport if you choose to share that data with someone else in the network, but it's going to remain at rest in your personal or organizational cloud storage utility. And then, of course, it can be encrypted at rest, or however you've configured your bucket or your blob container here. So very quickly, I'll show you how easy it is to just set up these services on Kaleido. We'll do a basic transfer right here, and then we'll look at the encryption layer as well. So I'm going to go to my B2B communications panel right here. I'm going to click on documents, and I'm going to add a couple of runtimes. So I'm going to call this docstore1. I'm going to provision it in our only available cloud and region. And I'm going to go with Kaleido storage here. But if you wanted to integrate with a S3 bucket or a blob container, this only requires a handful of configuration parameters in order to do so. So similar to nodes, based on the storage, based on the number of transfers that you're going to need, you can choose different document store instance sizes. We're not going to be doing much, so I'm going to go with small for each of these. So as that guy's provisioning, let's go ahead and make another doc store instance for our other membership. Call it docstore2, and we'll go with Kaleido storage as well. So the other piece that fits hand in hand with these services is what we call our ID registry. Maybe I'll drag this over here so I don't have to keep scrolling through 10 different windows. So this is an on-chain service. This is an on-chain smart contract that's going to store the key value pairs. It's going to store that PKI crypto material that's used in the asymmetric encryption, that's used in the secure transport flow. So we're going to have organizational identities, X509 based organizational identities, and then underneath those attestations, you can have key value pairs. And what we'll see with our document store service is we're going to have these concepts called destinations. So think of a destination just as an inbox, right? Mailbox, or your email address. And this is just something that other participants. It's a location where they can send you data. You can have many, many destinations inside of your document store service. The takeaway is that every destination has a corresponding public certificate. It has a public key that the counterparts can use to do that asymmetric encryption. So what happens here, not to go ad nauseum down the, the crypto transport layer, but for each transfer, there's a unique PKCS7 symmetric key that's generated. That's used to encrypt the entire payload. And then that key itself is actually wrapped in the participant's public certificate. So the symmetric key is part of the overall payload, and then it is encrypted with another layer that can only be decrypted by the private key that's held by the receiving entity in the network. So they would, begin by decrypting that symmetric key, and then they can unravel the whole payload right there. And they'll also send back a signed verify. They'll send back an ACK or an acknowledgement that the delivery was confirmed. So you have these really, really powerful proofs right here that you can also add to the blockchain, that attestation or that delivery confirmed call as well. So what we need to do now, as these services have stood up, is we need to deploy that registry service, and we need to create the underlying crypto material that allows us to have these destinations. So, okay, back into Kaleido right here. So I'm going to click on my destinations tab right here. It says no destinations have been created yet. So I'm going to click add destination, and it's going to let me know, hey, there's a lot of things that you need in order to be able to do, to have a destination and to be able to perform, that end-to-end encrypted transport. So the easiest way is just let Kaleido do all this. We'll give you a self-signed organizational certificate. We'll actually invoke that smart contract with, the X509 proof and a corresponding Ethereum address. And then when you create the destination, Kaleido will automatically insert that as a key value pair into your membership profile, into your on-chain profile. So this actually takes a decent bit of time, probably 30 to 40 seconds. This is going to deploy that smart contract, but it's also going to deploy the other microservices inside of Kaleido. It's going to teach all the other accompanying services about this metadata and about this, crypto material right here. So this is actually the longest part of the process, is to fully deploy the on-chain registry, all of the Kaleido microservices, and then teach all the other services about it. So I don't know, best guesstimation is probably 30 to 40 seconds. Once this is provisioned, it's a lot faster for the second entity to create their destination as well. So this last call is actually the invocation to that smart contract, passing the X509 proof and the corresponding Ethereum address. So we'll click next, and now we just need a name for the inbox. So this guy was ABC. I'm just going to go with ABC, and in about 10 or 20 seconds right here, this will create it. This will actually invoke that smart contract again with the key value pair, with the destination URL and that corresponding public certificate. And now we have a destination that we can use to sign transactions, outgoing transfers, or that another entity can use to send us information. So I'll go to DocStore2 and I'll do the exact same thing. Add destination, and we'll call this guy XYZ. So we see that it already knows that the on-chain registry, that smart contract is out there. So I can just let Kaleido create the X509 certificate and then invoke that smart contract with the proof and with the Ethereum address. Okay, so very quick for our second member, and we'll call its inbox XYZ. And again, about 10 to 15 seconds here. It's creating that URI, it's creating that public certificate and corresponding private key, and then it's uploading and invoking that smart contract with the destination and with the public certificate. And as soon as this finishes, what I'll do here is I'll actually go back to our address book, and we can look at those memberships. So we have an org ABC membership and an org XYZ membership, both of whom own a document store instance, both of who have had their memberships verified on the blockchain in the ID registry, and both of whom have a destination and corresponding crypto material. So if I click on that membership and I click on the on-chain profile here, what I see is I see that document, I see that destination URL, and then I see the corresponding crypto material. So maybe more interestingly, let's look at org XYZ right here. What we're going to do is we're going to upload, some dummy data to, the ABC DocStore instance, and we're going to send it to this guy. So what's going to happen is that one-time PKCS7 symmetric key is going to be wrapped in this certificate right here, and that will be part of the broader payload, of the whole payload. If you guys are interested in kind of the lower level nuances of how all this really works under the covers, I'd encourage you to take a peek at our documentation, specifically on the document store documentation. This is going awfully slow. And there's an architecture section right there. So if you click on the architecture, this will show you the 70 or 80 things that are actually happening under the covers. It ostensibly looks about as simple as possible, just pressing upload and pressing transfer. But there's actually a lot of magic in the transport and in the encryption that happens. So encourage you to read this if you're interested in any of those accompanying details right there. Okay, so let's hop out of here. Let's go back to our B2B layer and let's go ahead and upload a document. So we can click on our documents. I don't have any, and I can go ahead and upload my first document right here. So I will add, I just have a bunch of .text files. You know, this document store service, it's wonderful for, you know, arbitrarily unstructured data. So if you had images, or you had movies, or you had PDFs, or you had, you know, really extensive legal contracts. If you have really lightweight JSON or text payloads, we have another service called app-to-app messaging, which follows identical architecture, but it's more suited for, you know, lightweight payloads. The core architecture and the core functionality is literally identical, so it's not that important to dive into. But the document store service is really useful if you need to persist that data, or if it's large or unstructured data as well. So I'll just use this .text file, example private data 3 DEF, and then some arbitrary strings. So I'll upload that. And what we see is Kaleido is automatically going to hash that for us. And it's going to give us the ability to transfer that to any other destinations that are available inside of this environment. So Kaleido will auto-detect all of the available recipients, all of the available destinations, and within the dashboard, you'll be able to just use the drop-downs and transfer that data. So we can say we want the receiver membership to be org XYZ. It auto-detects their destination, and this is the sender destination that's going to sign that outgoing transfer right there. So go ahead and click transfer, and we'll see that this transitions from sent to received, and then we can go to DocStore instance number 2, and we'll be able to query that data. The other interesting thing that we'll look at inside of the application is actually this hashing right here. So this is just a basic SHA-256 hash of that payload. So, you know, it's really easy if, you know, if you're just using, using simple unstructured data, to just throw this into a different emulator right there. So I can actually grab that data right there. I can copy it, and we can compare the hashes inside of this little SHA-256 online. So copy that, and we can go to right here. Well, it looks like I had already pasted it from earlier, so we can paste that right there. And then we see the hash right there, 2BA54. If we go back into the document store instance, 2BA54. So this is nice, you know, when we're thinking of what we actually want to reference on the blockchain. This would be an example of, you know, how we reference that private data on the blockchain, along with maybe, you know, a name or some other metadata. Okay, so we can go to DocStore number 2 right here. We see that it's received this document. It can go to documents, received folder, destination, and then you can choose to download this document, compare the hash, delete the document, or send it to someone else inside of the network. So that's using document store at sort of a 101 level inside of the platform. Now what we can do is we can actually marry all of these features together, and we can look at how they work under the covers with an actual user interface and an application sort of exposed to the user. So I'll log out of this account, and I'll go into our demos account, where I have the necessary backend infrastructure already available. So we have this marketplace demo right here, and you're going to see a lot of the same things. We see 3 different DocStore instances, 3 different memberships, 3 different nodes right here. We can go into our shared assets folder right here, and we see 2 different contract projects. We see a marketplace contract. This is the bulk of our business logic, our source code, and then we see an ERC20 contract for payments as well. And then if we click on each of our nodes, we are of course going to see some rich event streams. So I can click on node number 1, click on event streams, and then we see all of the different pieces of functionality that can take place in this. Something was made available, something was purchased, something was rated, and just different acknowledgements with document store that that data was received or that data was paid for. Okay, so this is the backend. This is the underlying infrastructure right here. I'll just click on the Data Explorer tab for now so that we can inspect a transaction. And then we'll go ahead and go into these different instances. So we have 3 different instances of the DApp, one for org1, one for org2, and one for org3. And we see that they all have a corresponding token balance as well. So 3490 for org3, 2970 for org2, and 3540 for org1. And the takeaway here is really quite simple, right? And you can use your imagination and you can extend, the available functionality or just the different data types right here quite easily. But what we're looking at is we're going to have one organization publish some private data that might be of interest to other people in the network. This could be, a practitioner record in the healthcare space. This could be results of a pharmaceutical trial. This could be, something to do with annuities or something to do with insurance. Something to do with, a trade that was made or a legal contract that was signed or the deed to a house. Any piece of data that makes sense in your industry or your vertical. I'm just using those dummy.txt files for ease of use and simplicity. So what I'll do acting as org number 1 right here is I'll go ahead and publish a new piece of data. So I'm going to give it 2 different parameters right here, just the metadata. I'm going to give it an ID, 4 zeros and a 4. And I'm going to call this example private, if I can type, data 4. And then I'm going to go ahead and grab another one of those text files right there. So example private data 4. Again, it's just boilerplate nonsense, but this would be something of interest, or this would be PII, or this would be financially or personally sensitive information right here. But for the purpose of the demo and the actual flow of the information, this dummy data is fine. So I'm going to submit this, and this will result in our first on-chain transaction. This is going to be a published event right here that's going to be emitted. So we can see that it came from org A. We can click on it right there. We can click on the actual transaction. We see that it called the publish method right there, and that it uploaded that hash and then some of that high-level metadata. It has the key and it has the value right there. We can do the exact same thing. We can go and look at that data right there. We could put it into that SHA-256 emulator right here, and we'll see back the exact same hash. So this is what's being persisted to the blockchain. These algorithms are one way, so pretty near impossible to derive it, go in the opposite direction. So very, very secure practice to just take the hash of that data, and then any metadata that isn't overly sensitive, share that on the blockchain as well. Okay, so that's event number 1. Now what we see here, thanks to our event streams, is that both of these organizations, org2 and org3, about 20, 30 seconds ago when when that transaction was executed, they were both made aware of that action, of this new data. So immediately they know that there's new data that's been made available for purchase. They see when it was appended to the blockchain. They see who the author is, and any other information that would otherwise be available. So I'll grab both of these for org2 and org3. And then acting as org2, what we can do is we can actually use some of our token balance, and we can purchase this piece of private data, this healthcare record, or this legal document, or in our case, this text file. So I'm going to click purchase, and this is going to do 2 things. This is actually going to result in the transfer of that document using document store, and then an acknowledgement is going to be emitted from the receiver's document store, and a token transfer is going to take place. So we see that the document was transferred successfully and confirmed because the token balance was also decremented right there and incremented over here on this guy, 3550 right there. So what that was that was 2 transactions on the blockchain. So if we go back to our transactions tab, we'll see right here that we have org B right there that purchased, and then we have org B that confirmed the delivery of that private document right there. again, with a reference to the hash of that private payload, very easily available for your inspection. And now the last thing we can do, and this will be the easiest way to really sort of see the event streams in action, is acting as org2. Now that we've purchased this data, we can actually rate the data. We can give it some sort of arbitrary rating based on what value we were able to get out of it. So what I'll do is I'll rate it, and then we'll switch to the org3 DApp right here, and we'll actually see that update happen in real time thanks to the event streams that are emitted. So I'll click rate, we'll give it 5 stars since it was superb data. And then there we saw that happen in real time. So we're using Geth and proof of authority on 5-second block intervals. So it's possible for transactions to get executed in that 1 to 2 second range, or it's possible for them to be in the 4 to 5 second range. So just depending on the proximity to that block interval, it can depend when those events are going to be emitted right there. Okay, so that's gives us 5 minutes to the top of the hour. That's pretty much everything I wanted to show. I don't think I forgot anything. I'm sure I did, but I think that was a good synopsis of some of those core services and a good walkthrough of the platform and showing you how those can all work together, how you can delegate that storage to an off-chain cloud utility, how you can establish those identities, how you can interact with your smart contract, and how you can consume those events. And again, everything I just did, even creating the document store instances, this is available for any first timer or any user of Kaleido. You can create your own account, doesn't require any billing details out of the gate. You can stand up some nodes, and you can stand up to 2 what we call member services. So you could stand up 2 of these doc store instances, and you can experiment with transfers or with building out kind of the scaffolding of a full stack application. So I'm going to stop sharing, and I'm going to check the chat and see if there's any questions. If there are, I'd encourage folks to potentially ask those right now before we reach the top of the hour. As I'm dragging my feet, I'm going to share some contact information as well. So just bear with me here. There's the chat. There we go. Yeah, so if you guys do have any follow-up questions, technical nature, commercial nature, what have you, feel free to reach out. I'm going to share my personal work email and then a few other ways to get in touch with us. If you have a sales question, you can just contact sales@kaleido.io. If you have a platform or a technical question, you can contact support@kaleido.io. And again, this was recorded. You'll receive the recording. It'll be posted to the YouTube page. And we have some really exciting Tech Tuesdays coming up in 2021. We'll look at some of those more interesting lower level integrations on the node. We'll look at some identity integrations. We'll have some collaborative joint partner sessions looking at some real world consortia and some actual production grade use cases. Lots of fun stuff on the docket, and lots of new features and services coming to the platform as well. So if there aren't any pressing questions, I think we can call it quits for today. So I'll just finish by thanking everyone so much for attending. Again, hope you're staying safe, hope you're staying healthy. And if you do have any follow-ups, like I said, technical or commercial, please feel free to reach out to me directly or use any of those other mediums that I shared. So that'll do it for today's Tech Tuesday, and we hope to see you guys back for future sessions. Thanks so much.